This video is for section 9F. I'm on pages 17 and 18 in your chapter 9 note packet. Alright, so sampling with and without replacement. When we use the word sampling, we basically just mean we have a large group of objects, persons, places, or things, and we sample one at random and inspect it for particular features and record something. If the object is put back into the group before another object is chosen, we call that sampling with replacement. And if we take that object out, set it aside, where it's not possible to sample it again, it's called sampling without replacement. Sampling without replacement is often recognized in some context where we say we deal cards, or we draw things out simultaneously, we draw in succession, or we randomly select. It's often implied that we're doing those things without replacement. So we're going to see tree diagrams in this section again to display all the outcomes when two actions are done in sequence. And when we do those actions in such a way that we do sampling without replacement, we'll make sure we're adjusting the probabilities on the second set of branches to indicate that the second action is dependent on the first action. So if we're sampling with replacement, you will see me use the multiplication rule for independent events. While here, you'll see me use, for without replacement, the multiplication rule for dependent events. So a couple of model problems then to demonstrate sampling with and without replacement. I like the first one because you'll see side by side how to change the tree diagram based on how the sampling is done. Alrighty, so first problem here, we have two marbles drawn in succession from a box that has 2 purple and 5 green ones. Let's find the probability that the two marbles are different colors if we do replacement of the first in part A, or part B, the first is not replaced. Okay, so when you draw the tree diagram itself, it's going to be the same in both situations. We have a first pick and a second pick. So we have the first set of branches for first pick, and we're either going to get a purple or a green one. And then we have a second pick, where again, we're going to get a purple or a green. So when we put our probabilities on the branches, here's where it matters. If we take out a purple one, there'd be a 2 in 7 chance for purple, 5 in 7 for green. Now, as long as we're replacing that first one, the probability of purple again stays 2 in 7, the probability of green 5 in 7. So our probability tree, when replacement is happening, is there's no adjusting probabilities. So then when we put down our outcomes, we could get purple, 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 green, green, purple, green, green. 4 possible outcomes in this chance process. And then when we go to get probabilities, we're just using the multiplication rule for independent events. Small here. Okay, so we'll see 4 out of 49, 10 out of 49, 10 out of 49, 25 out of 49. So if you ask me for the probability that I get different color, I'm just summing which 2 branches do I need. I got a different color if we have a purple green or if we have a green purple. So I go to those branches and I add up the 10 out of 49 plus the 10 out of 49 and answer 20 out of 49. Okay, now if we do it in the scenario of the first not being replaced, that doesn't change the tree. Okay, we still have a tree where we get purple or green, 2 out of 7, 5 out of 7. But now if I'm not putting that purple one back, There's only 6 marbles left, one of which is still purple. If I'm not putting that purple one back, there's 6 marbles left, 5 of which are still green. If the green one is taken out and put aside, 6 marbles left, 2 of which are still purple. If the green's taken out and put aside, 6 marbles left, 4 of which are still green. Okay, so now when I look at the outcomes, still the same list: purple, 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 green, green, purple, green, green, and their probabilities when I multiply 2/7 times 1/6, I get 2 out of 42. 2/7 times 5/6, we get 10 out of 42. 5/7 times 2/6, I get 10 out of 42. And 5/7 times 4/6, I get 20 out of 42. So now when we ask probability of different color, again, we're still on those same 2 branches, this one or this one. So I go and add up 10 out of 42 plus 10 out of 42 and get 20 out of 42. Okay, so I like that intro problem. It shows you how important it is to pay attention to with or without replacement. So if you're doing the without replacement, we're technically adjusting those probabilities just intuitively on this second set of branches right here. And then when we're following these, calculating these probabilities, we are technically following the multiplication rule for dependent events. Okay, some more problems on put aside. Next page. Okay, Marie has a bag of sweets. They're all identical in shape. 6 orange, 4 lemon. She selects one at random, eats it. So that's your clue. She's not putting it back, and then takes another one. Determine the probability that both are orange, both lemon, blah, blah, blah. So let's draw Marie's probability tree. So Marie's probability tree looks like this. She reaches her hand in for a candy. It's going to be orange or lemon. She eats it, reaches in again to get another orange or lemon. So based on the description of the bag, there's 10 candies in the bag. 6 were orange, 4 were lemon. Now, she ate that orange candy, so there's a 5 in 9 chance of getting another orange. 9 still in the bag, 9 left in the bag, 4 still orange. So these probability denominators are 9. If she takes a lemon one, eats it, sets it aside, there's still 6 orange ones in the bag, only 3 lemon ones left in the bag. So when we look at our outcomes, we can have her eating 2 oranges, orange, then lemon, lemon, then orange, or lemon, lemon. The probabilities just multiply. So we get 30 out of 90, 6 out of 10 times 4 out of 9, we get 24 out of 90, 6 out of 10 times, 4 out of 10 times, that was 4/9. All right, lemon and orange is 4/10 times 6/9, that's 24 out of 90. And then finally lemon, lemon, 4 out of 10 times 3 out of 9 is 12 out of 90. All right, so I always do that before I even answer the questions. Now that I have that all worked out, when I go to do part A, the probability that both are orange, well, that's right there on my tree. That's 30 out of 90. The probability that the first is orange, both are lemon, that's LL. So right on my tree, I already have that down as 12 out of 90. First orange, second lemon, that's 24 out of 90. And then first lemon, second orange, that's 24 out of 90. Notice that you get a sum equals 1 because the probabilities therefore all outcomes in a sample space must sum to 1. Okay, and if we added those up, maybe I'll show you here that before I write just 1, I could confirm 30 plus 12 makes 42, plus 48 more, that does indeed make 90 out of 90, which sums to 1. Okay, final problem. Bag A has 3 red and 2 white. Bag B has 4 red and 3 white. 1 marble is randomly picked from A. Color noted. If it's red, 2 are added to B. If it's white, 2 whites are added to B. Our marbles then selected from B. Ooh, so they're trying to get all fancy and complicated on us here. Let's backtrack through this. Okay, so here we go. We're picking from bag A. That starts the sequence. Once I pick from bag A, it's either going to be a red or a white. If there are 5 marbles in bag A, 3 are red, 2 white, those probability branches are easy. Alright, so now it's the bag B where things got a little bit complicated. So we have to follow what's going on. Bag B, let's maybe make a little space for some extra details so we could follow the prompt. So if we take a red one out of A, we're going to go follow this sentence. If a red one comes out of A, 2 reds are added to bag B. So that means bag B is going to be 6 red, 3 white. Or it's going to be, if we're on the white branches, we're going to go to 4 red, 5 white. So bag B is going to be one of these options. Okay, so when we go to pick out of bag B, and we put down red or white, in the scenario of red coming out, we're going to have 9 marbles, 6 are red, 3 are white. If we took the white option out of bag A, we go to 4/9 red, 5/9 white. Okay, so a little extra detail here. But anyway, finishing my probability tree, I either end up with red, 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 white, white, red, white, white, and the probabilities are, as in the other ones, just found by multiplying. I always fill out the probability tree before I even read the question. I don't want the question to confuse my process on this part. Okay, so multiplying out to 18 out of 45, 9 out of 45, 8 out of 45, and 10 out of 45. Let's check. 18, 27, 35. This does sum to 45 out of 45, so nothing's wrong on our tree. Okay, so after all, the question at the end is, what's the chance that the marble we come out with from B is a white one? So at the end of this process, what's the chance we ended up with a white marble in our hands? We have a white marble in our hands. If a marble is selected from B, what's the chance that the marble selected from bag B is white? That happened on this outcome. Whoops. That happened right here and right here. So we go to the two branches that count for a white one being taken from bag B and sum those two probabilities. To get 19 out of 45 for a final answer. That ends the material in section 9F.